Hi everyone. Let's take a look at a normal distribution. So this is the histogram dropping the two outliers that we had of the heights of the students in our class. And it's not everyone. It's only so it's about 23 students that are here. And here's the heights that we have. Again, remember, Google isn't showing me the number here, but so that we realize the counts. There's one student between 60 and 63 inches, 4 between 63 and 66, and you can see the rest there. All right, when we did the descriptive statistics, I found out with this information now that the mean, so sometimes we see it as a mean, but we're going to start thinking of this as a normal distribution, so I'm going to use mu. The mu is 68.25, and I'm just going to round that off to 68. The standard deviation, we've seen it as S, but again in the normal distribution we're going to use the Greek letter sigma. The standard deviation is going to be approximately 3. So I've rounded these things off so that we can see it in the context of the normal distribution. So a normal distribution is really a density graph. So here is what a normal distribution looks like. If you think about it, I'm kind of going back and forth. This isn't perfectly normal. I can actually tell because the median when I look at this data was 68 that it is pretty close to being normal and not skewed either direction. So the fact that the median or the mean is 68, I can kind of picture this graph using what we call the normal distribution. And the reason I always think that it's normal, and the fascinating thing about this is that because of the way that it's set up, we can use this same chart and these same percentages that I'm going to show for every single normal distribution. And that's, I suppose, the why we call it a standard deviation. So here I'm going to first put in that this was our standard this was our mean of 68 inches in the class. All right. You'll notice along this chart, going both directions, it shows 1 sigma, 2 sigma, 3 sigma, which is 1 standard deviation, 2 standard deviations, and 3. The idea of a standard deviation in ours, again, was approximately 3, is that I'm always going the same distance. I'm always going 3 from 68 to 71, and from 71 to 74, and 74 to 77. That's the idea of that standard deviation. And it goes the same way going the other way. If I subtract a standard deviation, subtracting 3 for each of these, you can see that here is, I suppose, what would be the normal distribution. Now, what does that really mean, or why do we do it? And this is where a lot of people struggle. It's dividing up this area in here and using this normal distribution so that we can kind of measure the percentages of people. So in this first column, and I'm going to go ahead and use like a yellow. In this first column, I shouldn't say first column, the middle 2 columns, all right, that's 1 standard deviation away from 65 all the way up to 71. Now, the important thing to know about that is this is 68% of the students, okay? So when you're using a statistics, we're always trying to kind of say with some degree of certainty, like where do we expect, how tall do we expect? I expect in my class that about 68% of my students are between 65 and 71 inches tall. Seems a little high, but that's what, I guess not. I suppose the average height in the United States, I believe, for men is 5'8", and for women, I think it's 5'6". So that seems about right. I don't know how many male and female students we pulled here, and we did both genders. So 68% are in that first standard deviation. Okay, if I go to a second standard deviation, and I'll just go from 62 all the way up to 74. All right, that ends up being 95% of all of the students. Okay, 95% of the data is going to fall between those 2 standard deviations. And finally, if I go from 3 standard deviations all the way across to 3 standard deviations, now we're talking about 99.7% of all of the students. So what's interesting, and because it's symmetric, is I can now go through and kind of break up these numbers. So I'm gonna break it down into the individual parts here and kind of show you how I do that. 50% is right here in the middle. You know, everything less than that is 50%, everything more is 50%. So it's symmetric. 68%, if I divide it in half, I end up with 34% here and 34% here. Okay, 95%, I always find it's a little bit easier for me to figure this out. 95% really means that there is going to be 5% going this way. So there's 2.5 and 2.5 on both sides. All right, and if you think about it, this whole side has to add up from here all the way to the end is 50%. So it makes it a little bit easier. 34 plus 2.5 plus it would end up, so that's 36.5, so I end up having to have 13.5% here and 13.5% here. All right. Now the key to remember is 99.7 goes all the way to here, which means 99.7. 100 minus 99.7 only leaves me with 0.3%. If I break that in half, there's 0.15% out here and 0.15% out here. So now I'm going to show, like, putting this together, what I've got in that inside part. I've got from here all the way out. I know I already have 34 plus 13.5 plus 0.15. All right, so I have 47.65%, and that leaves me with only 2.35 in these little columns. All right, we normally don't have to break it up this much, but I just wanted to show you how it's kind of put together. We're really just, I would say, I would really be interested in remembering 68, 95, 99.7. All right, so let's take a look at what this kind of means when it comes to using a standard distribution. I can do this with anything. I did it right here with the heights of the students. I can do this with whatever data that we're collecting, as long as I know two things. I need to know what's the mean and what's the standard deviation. If I know those two things, I can make this exact same chart again. So let's do that, and I'm going to grab another example here, and we'll make a chart out of that. All right, so here I have a chart of, and this was kind of self-identified, how good are you at math from 1 to 5. It looks like the mean was about 3.3, and the standard deviation was about 0.86. Okay, so I'm just going to round those off to 3 and 1 so that we can put it into this other thing. And remember, the score is only 1 to 5, so 3 and 1. What I'm looking at here is, and it's telling me that about 11 of you have decided you're somewhere between 3 and 4, as how good at math you are. And that's awesome. So let's jump back over here and say the same thing. Starting with my standard deviation, or my mean. My mean is 3 with a standard deviation, so mu is 3, and standard deviation of 1. That makes this really easy. That makes this 4, 5, and 6. And here we have 2, 1, and 0. So what this tells me, 68% of the students I expect to be between 2 and 4. All right. There are going to be about 95% of the students are going to be between 1 and 5. And I think this is going to illustrate something that, we don't have a very large sample size. I didn't even give you a choice to go up to 6. All right. But apparently, if I were to ask people this question, I'm expecting about 2.5% of the population to be greater than 5. Like they're 5 and above. You know, they'd probably pick a 6 if they could. About 2.5% kind of think they're worse than 0. But again, kind of shows you kind of the idea about using a normal distribution and plotting these things in here. Keep in mind that the standard deviation, this chart doesn't change. The percentages don't change. The only thing that changes is what is your mean and how far is each standard deviation away. So hopefully that will help you understand a little bit more about standard deviation and the normal distribution.